Hey, what's up everybody? I'm going to be going over this exam. Measures of center, standard deviation, empirical rule, Chebyshev's inequality, linear regression, correlation, coefficients, things like that. Let's get right to it. Question number 1, determine whether the quantitative variable is discrete or continuous. And it says time in hours. That's continuous. Time is continuous. And it is not countable. Observational study versus designed experiment. Well, observational study measures the value of the response variable without attempting to influence the value of either the response or explanatory variable. Yeah, but what does this say? An observational study is when a researcher assigns individuals? No, that's an experiment. So the answer would be that first one. Number 3, construct a frequency distribution with first lower class limit of 0 and a class width of that. Okay, frequency distribution. All right, let's do this. How do we make a frequency distribution? We copy the data, press copy. We scroll up. Open StatCrunch. Go to StatCrunch. StatCrunch website. Open StatCrunch. Press Control V. We're trying to make a frequency distribution. So I'm going to go to data first. Need to bin the data. I'm gonna pick the first column. If the question probably said something about, let me go to the question. Okay, first lower class limit of 0 and a class width of 180. So what we do is we put 0. We'll click this, use fixed width bins, 0, 180. Okay, that's it. That's the first step. Okay, so we got these binned data. All of our data is categorized in different bins. So now I'm going to go to stat, tables, frequency, click the binned data and do frequency distribution. Press compute and that's it. There's your answer. And now you're going to have to, if you're taking an exam, you're going to have to take a screenshot of this somehow. So I'm going to do new. I'm gonna go like this. I have to save it. I do something like file, save as, and I'll just say screenshot. So I'm gonna save this on the desktop as screenshot, and then when I go to my quiz, I'm just gonna demonstrate this once for you guys. You hit insert, you go to image, upload image, click this, and go to screenshot. And there it is, press submit, and that's how you insert a screenshot. There you go, there it is. So I'll just do that once just to show you guys how to insert a screenshot during an exam. Okay, next question, graph an Ogive from this data set. Okay, it gives us the first lower class limit of 0 and it gives us a class width of 32,000. So let me show you how to do an Ogive. You copy the data, press copy, go to StatCrunch. You can put the data right here if you want in variable 3. So I have the Ogive. I have this is for my Ogive, right? That's for my Ogive. I have to bin the data again. So I could actually go to edit. I binned this one, so I'll just change it to Ogive. And I have to look at my test. It said, okay, use a first lower class limit of 0 and a class width of 32,000. Wow, 32,000 is pretty big. 32, 1, 2, 3. That's it. Our binned data is right here from the Ogive. Now to make an Ogive, this is tough. Ogives are tough. They're cumulative frequencies. So I do stat, table, frequency. I just need to do Ogive stuff. Cumulative. Press compute. There's 2 types of Ogives, a relative and then a regular one. So I'm just gonna press Control C. I'm gonna paste it here in variable 5. So that's my data from my Ogive. Let me get rid of some stuff. Alright, this is tricky. Ogives are tricky. I want to use the upper limits, 32,000, 64, 96. How do I get rid of 0, 2? Well, there's some tricks you can do, tricks of the trade. If you want, you can do this. You could cut it and then scroll over all those cells, press Control V, and it'll do this thing. paste preview, you can use white space as delimiters and see how it's gonna paste it for you, all nice. See how it splits everything? So I don't need this anymore. Don't need this. I'll call these my uppers. For an ogive, you actually need to use the upper limits. Ogives are tricky, so what I do want to, now I'm gonna do something real. Watch what I'm gonna do right now. Press Control V, I'm gonna cut, and I'm gonna put a 0 right there. I'm adding, and I'm gonna put 0 right there, because it's going down by 32,000. The class width is 32,000, so I'm adding a 0 right there. For an ogive, you need to start at 0. So whatever your class width is, you can just go to this class, subtract your class width, go down to 0. And that's what I need to sort of make for an ogive, okay? And then once you do that, then it's easy. Just go to graph chart columns, click cumulative frequency, I believe. Is that what it's called? Yeah. Yep. And then row labels, I'll put the uppers. And my plot type, I should do points with connected lines, and that's it. So there you go, there's your answer. So just copy paste that in. You can right click this, press copy image, and well, that's probably not going to work for you. You may have to save it. You may have to press save or do a screenshot and then save it that way. You know what I mean? Save it to your desktop, give it a good name so you don't get lost later on. Maybe you say something like file save as and just call it Ogive, you know what I mean? So whatever, you got to figure out how you're going to do that, how you're going to save stuff, how you're going to name things that you save. So that's it, that's an Ogive. There you go. Notice that it's a cumulative, it's cumulative in a sense that it keeps going up and up and up. It never goes down. It's just always going up, always going up. Next question. One exam score is missing below. The scores are in ascending order. The median of these scores is 61. Find the missing exam score. Okay, for this question, this is a Desmos. I think I'm going to use Desmos on this one. So look, notice that the data is in ascending order. So that means that this value, that's underlined value, it's bigger than 50 and it's smaller than 77. So that means that this unknown value, let's call it X, and 50, those are the middle two values. Do you see that? Those are the middle two values. To find the median, you take the, if there's another thing is to notice there's an even amount of data. An even amount of data. 3 on the left, 3 on the right, including the underlined value, the missing value. For an even amount of data, the median is the mean of the middle two values. So 50 plus X divided by 2 should be equal 61, right? Over 250 plus X divided by 2 should equal what? 61, we said. So from that, we can say 50 plus X should be equal 2 times 61. That's 122, right? From that, we see that if we subtract 50 from both sides, we get X equals what? Is that 50? 72? Yeah, so that's it. The answer is 72. See how that works? Okay, next question. The answer is 72. You need to show your work for the exam, so you may want to just copy this, say press Control C. On the exam, you got to show your work. So you go in here and you say insert equation and just scroll down and press Control V and see if it works. Didn't work, it's giving latex. So what you want to do is you want to go in here, edit equation, and just change it to, so you switch to basic, what happens? Let's see. The equation cannot be rendered in basic view. Switch to advanced, press Control V, and there we go. It works now. We had to insert it in the advanced mode. So if we press that, then that's how you insert it. I mean, right now it's black. You can't really see it because it's black on black, but anyways, I just wanted to show you how to insert something, and I wanted to mention, hey, you got to show work, right? You got to show your work. Is there a way to change the font? I think there is. I think I can. Pick something. There we go. Ooh, it's no good. Alright, anyway. It's not the point of this, not what I'm trying to show you. Next question. According to the US Census Bureau, the mean of the commute time to work for a resident of Fresno is 60 minutes. Assume a standard deviation 18. What minimum percentage of commuters in Fresno has a commute time within 2.1 standard deviation? This is definitely Chebyshev's inequality. This never says that it's normally distributed. Also, this is 2.1. That's a weird number for the empirical rule. So we got a mean of 60, a standard deviation of 18. I'm going to use Chebyshev's inequality to find the percentages. I actually only need the 2.1. So I'm going to go here. And so for Chebyshev's, I know that it's 1 minus 1 over k squared. So it was 2.1, right? So 1 over 2.1 squared. And that's your answer. So the answer would be 77.3%. So your answer, you would, I mean, that's pretty much it. You can show this stuff as your work. If you want, you could say equals, and then just, you know, copy this. We'll round that. Maybe we'll round that. 77.32%, whatever. If you want to say it as a percentage, you could say 77.32%. And you could just copy this and paste this into Desmos if you want, and that's it. So the answer is 77.32%. What are the commute times within 2.1 standard deviations of the mean? The commute times. Okay, here's where we need the 60 and the 18.3, because 18.3 is the standard deviation. So the k, the 2.1, it says within 2.1 standard deviations. So we got to multiply 18.3 times 2.1, and then we got to add and subtract that from 60.2. That's it. So you could do something like this. See, 18.3, 2.1. Okay. Let's say something like, oops, why did it say of? I don't like that. Now I forgot since I got distracted there. I had it in my brain. 60.2. I think I have it. So there you have it. That's one of your values. You can copy this into Desmos if you want to show your work. Remember, you got to show your work. I'm gonna copy this, paste it, and I'll change this to plus. And then of course, let me get rid of this. Oops. So that's gonna be the 2 commute times right there. Control C, Control B. And you can, you know, copy paste this into Desmos if you want. These two things. These two things are your answer. 21.77 and 98.63. Those are your answers. Those are the 2 commute times. You know, so make sure you know, don't be afraid to write a sentence, explain what you did, or insert your work or stuff like that. The grades on an exam were bell-shaped and symmetric, and had a mean of 72 and a standard deviation of 8. What percentage of students scored between 64 and 80? Okay, so we got 72 now. Now to think about this question, look, if you're at 72, that's the mean. If I add 8, I get to 80. So it seems like the answer is going to be 68%, because that's 1 standard deviation up. Also notice that it's bell-shaped and symmetric, so that means we're going to do the empirical rule. And notice if you subtract 8 from 72, you get 70 minus 6, which is 64. Yeah. So for A, the answer is just 68%. If you wanted to show your work on A, you could do something like this. You could say 68% since sometimes I can't write sine because that's a trig function. 68% since 80 and 64 are 1 standard deviation from what was it? 72. You could just write a sentence like that, or you can show your work. You can say something like, note. I would do that. I would just say that, a sentence, or you could say something like, note, 72 plus 8 equals 80, and 72 minus 8 equals 64. So the answer is 68%. You know what I mean? You're sort of showing it mathematically. Those are two ways to show your answer for part A. Okay, part B says 95% of students scored between which two test scores? Of course, we'll use 72 and 8 and we'll multiply by 2 for that one. So for B, you'll say something like 72 plus 2 times 8 equals, what's that, 16? 72, 82, 88, that's 88. And then 72 minus 2 times 8 equals, because 16 is 60, 72, there we go, 56. All right. Anyways, so those are the two answers. So you could say between 56 and 88. You gotta be write sentences, write small sentences to sort of say what you did and what you mean, what you want to say, your conclusions, you know. Okay. All right. So that was number 7. Number 8. Copy the following into StatCrunch. The accompanying frequency distribution represents the square footage of a random sample of 500 houses that are owner occupied year round. Approximate the mean and standard deviation square footage. So we're gonna take this data right here. We're gonna copy it and we're gonna try to find the mean and standard deviation. The key to this question is to know that it's grouped data. That's the key. This is grouped data. This is not regular data. So we gotta know how to handle grouped data. We need to know how to find the mean and standard deviation of grouped data. Let me get a new data table. This is kind of full. I'll come over here and I'll put Control V. I'll press OK. There we go. That's our grouped data. Now for grouped data, to find the mean, you go the same place you get the mean at, but instead of picking columns, you pick grouped data. And then the bins we'll call square foot, counts, frequency, and that's it. We'll use consecutive lower limits. And then that's it for the mean. We only needed the mean and standard deviation. So let me go back in here and say mean and standard deviation. Press compute. Now this may be wrong. I just realized that this standard deviation might be wrong if it's not a sample. So let me go back in here. And it is a random sample. If it would have said population, then I would get the answer wrong. So be careful. This is a random sample. So that means we did it right because we used stdev. If it didn't say stdev, if it said population, I would have had to get the unadjusted, right? If I scroll down here, this is the population standard deviation. We call it sigma. So keep that in mind. Okay, anyway. So that's the mean and standard deviation, right? Those two. This is correct. And notice that the mean is 2,200 square feet, which makes a lot of sense because 325 is the biggest frequency. So 2,200 should be somewhere in here. The mean should be here. This is around the center. The peaks are around here, right? So the mean should be around 2,000, right? So it makes sense. The mean shouldn't be like 100. If you just took these data here, all this data here, the frequencies only, you're gonna get a mean of like 100. But square footage is 100 square foot. That doesn't seem like the center. Down here? No way. All right, next question. The following are ages of people in a community. Determine if there are outliers. And if there are outliers, tell me which numbers are outliers and justify why they are outliers. Okay, let's see if there's any outliers. How do we check for outliers? We got to get the fences, right? So copy, go to StatCrunch. We can plug it in right here. Variable 3. This is for our outlier stuff. Outliers. So I'll just label that just in case I forget where I put it. So I'm gonna say outliers. Oh, I'm just gonna go to stats, summary stats, columns, and I'm gonna pick outliers. And all I want for outliers is the median. Actually, I don't even need the median for outliers. I only need Q1 and Q3, and I'll take the IQR just for good measure. Where's the IQR? Right here. Boom. Press compute. All right. So what we gotta do with these? So 20, 26, and 6. Okay, 20, 26, and 6. So 20, 26, and 6. 20 is Q1, 26 is Q3 because it's bigger, smaller, bigger, Q1, Q3, and 6, that's the inner quartile range. Now, here we go. Lower fence equals 20 minus 1.5 times the IQR, which is 6. That's 6 plus 3 is 9. This is 11. Okay, and the upper fence, by the way, this is work you're gonna have to show if you want to get full credit. 26 plus 1.5 times 6. What's that? 9, that's 29, 35. Okay, so our lower fence is 11, our upper fence is 25. We need to see if there's anything smaller than 11 or bigger than 25. If there is, those are called outliers. So this is the work. You gotta copy this work. I wouldn't copy this necessarily, but at least do this, showing how you got the lower and upper fence. Okay, let's see. How do we identify our outliers? Is this data in order? Ooh, it's not in order. I get to do something cool. I'm going to sort the data. So I'm gonna go to data. I'll look for sort, and then I'll just pick outliers, select columns, outliers, and I think it wants me to do outliers again. I'm not sure why, but I'll just press compute. Close this. Close this. Look, our data is in order. Now, it's in order, so that's helpful, very helpful, because now I can see that there are no lower outliers because there's no number smaller than 11. And then what about upper outliers? Okay, as far as upper outliers, I got 43, 41. Now what was my upper again? My upper fence? Wow, 25 is the upper fence. Okay. Jeez, there's a lot of outliers. Dang. Whoa. 26, 26, 30, 30, 30, 30, 32. Oh my goodness. So yeah, all of these are outliers. Anything bigger than 25 is an outlier. So we have a lot of outliers. Jeez, 26 through 43, all of these values right here, all of those. And you have to say, how can I grab them? 26, 20, there's two 26s, 4 30s. So yeah, you just list all those numbers like 26, 26, 26, 26, 30. I've never had this many outliers. 30, 30, dot, dot, dot. Are outliers since they are bigger than the upper fence. I don't know why it doesn't like fence. They're bigger than the upper fence, which is 25. So you can show your work like that. You can list all of the outliers and say all of those are outliers since they are bigger than the upper fence. And that's how you show your work on that one. All right, moving on. For the following data set, determine if there is a significant correlation. Make sure you justify your answer. Okay, let's try it. Let's grab the data. We'll press copy. Correlation, significant correlation. Okay. Significant correlation. To put it right here. Maybe. Okay, that works. So put it right on this page. We can ignore all this stuff here. So we only have X and Y. We're worried about X and Y. For correlation, to determine a significant correlation, the R value needs to be bigger than the critical value. That's it. How do you get the R value? Simple. Stat, regression, simple linear gives you all of regression stuff. So X is X, Y is Y, and that's it. Press compute. Our R value is right here, and our sample size is right there. So that's stuff that I want. Watch, I'll copy that. And okay, so I'm gonna go here, I'll press Control V. I gotta see. Got a sample size of 20, R value of that. I want my critical value. My critical value equals critical value. Announcements. Formulas for test 1. We got sample size of 20, right? Okay, so 0.444. There it is, 0.444 right there. So critical value, because remember the sample size is 20, so it's 0.444. Okay, now we care about the absolute value of R, so really positive 0.27. So we could, if we want, we could say absolute value of R equals to 0.276 is less than 0.444, the critical value. So there is not a linear correlation. Okay, that's it. That's how you do that. I mean, you could look into the graph and make sure there's no influential points. If you really wanted to impress me, you can make a graph like a scatter plot. Like you can look at the scatter plot by pressing the right arrow and you could say, oh, there's no influential points. It looks pretty normal. It's not like all of the data's bunched together over here and you have like one point like way over here. You could insert this and say there's no influential points, so we're safe to say there's no correlation if you wanted extra credit. Alright, next question. An engineer wants to determine how the weight, okay, whatever. Should you use y hat or y bar to make the prediction? Okay, y hat is used if there is a correlation. Y bar is used if there's not a correlation. That's it. That's it. So just figure out if there's a correlation in the same way we just did the last one. So that's how you answer part A. So watch. Copy. Go to StatCrunch. Put it right here perhaps. Press OK. So we got weight in miles per gallon. We're using the weight of a car to predict the miles per gallon. So I'm just going to go to stat. Regression, simple linear. Once again, weight and miles per gallon. Press compute. We have the same sort of stuff to do. Ooh, that's a high R value. For this one, we'll click Control V. Okay, I got a sample size. I mean, this R value is extremely high. I already know, but still, even though I know it's gonna be a correlation, I still need to show my work, right? Now, where was the work? Oh, sample size of 10. It's right here. 0.632. 0.632. 0.632. And then check this out. I'm going to say the absolute value of R, which equals to 0.971, approximately is greater than 0.632, the critical value. So there is a correlation. There is a correlation because of that. All right. So that's kind of like you need to show this work, right? Like this and this, you need to copy, put it in somehow, copy and paste it into the test for the exam. That was part A. Now, we're actually not done with part A. Should you use y hat or y bar? Well, we're gonna use y hat now. We just proved it. Since there's a correlation, we're gonna use y hat. So we can write that down as our answer. We could say, so we use y hat. Because there was a correlation. We showed that there was a correlation, and that tells us to use y hat to make the prediction. So you can write that on the test. Part B. A certain gas-powered car weighs that much and gets 20 miles per gallon. Is the miles per gallon of this car above or below average? Above or below average? Okay. How do we do this? Tough one. We're gonna plug in 3558 into the regression line and figure out the predicted miles per gallon and see if it's higher or lower than 20. So we're gonna do 3558. Now watch, I'm gonna show you something pretty dang awesome. This is gonna be pretty dang awesome. Let's see. I have this miles per gallon predictor or a regression line right here. So watch this. This is gonna be so cool. Watch this. Scroll down to where? Ooh, predicting y of an x value of 3558. This is so cool. This gives us a predicted y value right there. The x value, if you have 3558, double check that. Was it 3558 correct? It'll give you the prediction. Basically, it'll plug the 3558. It'll plug it into the equation. But this is so much convenient. It's very convenient because otherwise I would have had to do this. This is not the end of the world, but I would have had Control C, Control V. I would have come here and put times 3558, and I had to get rid of this. Now watch this. So you could have done this. Now look at that. I just plugged it into the regression line, right? I got 18.23, right? I could have done that, but check this out. If I scroll down, 18.23. Look, StatCrunch does it for us. So beautiful, such a time saver. If you do that, make sure you copy this so I know how you did that. Otherwise, copy this so I know how you did it, and just do this. Control C, Control V. Otherwise, just copy that in for your work. You got to show your work for part B, right? So we're predicting 18.23. So now we'll say this. What is it? What wording is the miles of this car above or below average? It's above average because he's getting 20, but we're predicting 18. So he's getting 2 miles better than what we predict. So we'll write that down, right? We'll say it's 20 miles per gallon is above average, which is 18.23. See? 20, the person's getting 20, but we predict 18. So they're doing better than normal. That car is pretty gas efficient. Next question. Part C. Does it make sense to interpret the y-intercept of the least squares regression line? If it does, interpret it. If not, say why not. It does not make sense because you can't have a car that weighs 0 miles per gallon. Make sure you write this stuff down. You always got to write down your answers. It doesn't... The y-intercept... The y-intercept doesn't make sense since you can't have a car with 0 weight. It's impossible. It's impossible to have a car that weighs 0 pounds. And that's it. Next question. Okay, the weight of an object, blah blah blah. If an additional object like that, is it influential? Ooh, influential. This is a lot of work. We'll skip part B. I'll actually do part B, but dang, this is a lot of work. We're just trying to figure out if it's influential, this additional point. All right, a lot of work. Let's do it. Copy. This requires 3 amounts of information, so I'm gonna go to new data table. I'm gonna paste it right here. Control V. Press OK. I'm gonna do this. I'm gonna go to stat, regression, simple linear, determine if there is a correlation. First, let me look at this data. Nope, it does look like there's a correlation, and it does not look like there's an influential point. But I need to show that mathematically by grabbing this, Control C. This is step 1, right? Step 1. To show something is influential, you need to go through this process of this comparison, right? For n equals 11, we have a critical value equal to, for n equals 11, let's see, where'd I put it? 0.602, you see that right there? 0.602. 0.602. Now I'll say that R is greater than, R equals to 0.879, or yeah, 879 is greater than the critical, greater than 0.602. Oops. So there is a correlation. Okay, now step 2. If I add the additional point, is it still a correlation, or did the conclusion change? That's what I want to figure out for step 2. So I'm gonna go to the question and read that there's a weight of 95, distance of 19. So I go here, I put weight 95, distance 19, and I press options, edit, and just press compute again. And notice that we have a sample size of 12 now, so that changed. That's good. That's a good sign. I gotta do the same process. I told you this is a lot of work. Here we go. Control V, sample size of 12, comma, critical value equals, let's see, for a sample size of 12, we have a critical value 0.576. Okay, 0.576. Now I'll say, take a look. Wow, it's still correlated. Ooh, look at that. R is equal to 0. It was close. It was a close one. That's greater than 0.576. So there still is a correlation. Nothing changed. The point was not influential. That's your step 3. Since the conclusion didn't change on the correlation, oops, the point wasn't influential. The point was not influential since conclusion did not change. That's it. And okay, this is such an easy question, but we didn't really talk about it a lot. It says, what percentage of the variation in how far the objects can be thrown is explained by the regression line? That's just r squared. So the answer would be 34%. So you can write 34%. That's your answer. That's it. 33.93%, right? It's just r squared. Now, do they want me to add the point or not add the point? Should I give the r squared value from having this point included or not? I don't know. The question's poorly written. It should say with the point or without the point. So, but anyway, that's just r squared. It's the percentage of variation that is explained by the regression line. Okay, for the following data, you need to determine what you would use for the center and spread, which is the dispersion. Figure that out. Show why. Show why. Okay. What should we use for the center? Should we use the mean or the median? What should we use for the dispersion? Should we use the standard deviation or the interquartile range? If the data is symmetric, we're going to use the mean and the standard deviation. If the data is skewed, we're going to use the median and the interquartile range. That's it. That's it. That's how you do this question. So let's do it. I'll show you how to do it. Copy. Come here. Right here. Control V. Now what I'm going to do, something real quick. I'm just going to make a histogram of variable 3. What I just pasted. Look at it. It looks skewed right. It definitely doesn't look symmetric. And that's it. Now I know to use the median and the interquartile range. That's it. That's all you do. Maybe insert this graph to show your work and say something like, to show your work, you could say the data from the attached histogram of the data, we see that the data is skewed right. Therefore, we use the median and the IQR. That's it. And how do you find the median and IQR? That's simple. Just go to the data and do stat, summary stats, columns, and then just get the median and the IQR. So where's the median? Median. IQR, press control, boom. Get them both, and there you have it. The median is that. So you'll say we use 31.34 for the median and 38.03 for the IQR. Make sure you write that down. Type that down. Write down all your work and your conclusions. And I think we're done. Let's check. All right, I hope that helps.